All right, people. I believe everybody is doing great, nice, and absolutely fine. So, welcome to this beautiful session. In this particular session, we're going to be talking about that is what we call the projectile motion. And before everything, I just want you guys to tell me in the chat if I'm perfectly audible, visible to each and every single one. Okay? Let me know in the chats, everybody out there. Am I perfectly audible and visible to each and every single student? Okay. If I am perfectly audible and visible, give me a thumbs up or fire emoji in the chats. Okay. And my dear friends, we are going to basically kill this entire chapter over here. Every problem I'll be showing you, every case we'll be discussing in this particular chapter, and it will be one shot projectile motion. We will try to complete the entire chapter in one go. Okay. So guys, everyone means everyone, and make sure you hit the like button. If you have not liked this session, and I would want you guys to hit the like button as soon as possible, because liking this session is extremely mandatory. Okay, marking the attendance is extremely mandatory. Guys, when it comes to the kinematics chapter, or you say projectile motion, these are important chapters from, we say, NEET perspective. Okay. So I will be starting from the scratch. I will be starting from the basics. Okay. You don't have to worry about anything. If you haven't studied this chapter before, if you are learning this for the first time, let me give you the assurity. I'll give you the guarantee over here only that you will be able to understand each and every single thing. And once we are done with the chapter, you would be able to solve every problem afterwards. Okay. So let me start this particular chapter without wasting your time. Let me start this particular chapter. And before this, let's have a look. Okay. Let's have a look on one-dimensional motion. This I have already explained before, but let me just tell you, I just want to explain it once more. Okay. And then we have got the two-dimensional motion. Guys, understand very carefully. Let's suppose I have got a car over here, or let's suppose this is a block over here. Okay. And this car is moving in this x direction, something like this. The car is moving along x axis, something like this. So it is the motion in a straight line. It is not the motion in a curve. It is the motion in a straight line. Now, if I say, sir, let's suppose I make the coordinate system over here. This is y-axis and this is x-axis. And if I say this car is, let's suppose, moving something like this, we say here its value is, it has reached x is equal to 1. We say here it has reached x is equal to 2, and so on. But its y coordinate here is not changing. Y coordinate is not changing. It is only moving in one direction. That is which one? X direction over here. So we say this is what we call the one-dimensional motion, in which particle is moving only in one dimensions, either x or y or z. Okay, like let's suppose you have got a ball over here. Okay, you have an object. You're dropping this object from certain height. Guys, understand very carefully. You're dropping this object from certain height. It will fall. We say, sir, it will go down, 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 down. Okay. Sir, is it one-dimensional motion or two-dimensional motion? It is a one-dimensional motion. Why? Because here only y coordinate is changing. Its vertical distance is only changing. And here, we say x coordinate is changing. So this is also one-dimensional motion. Okay. I believe till over here, everything is crystalline clear. I believe till over here, everything is crystalline clear. Okay. Okay. And guys, if you have not liked the session yet, I would want you guys to hit the like button as soon as possible. Okay. Now guys, see, let's talk about the two-dimensional motion. Sir, what is two-dimensional motion? We say when particle is changing two of its coordinates, we say here, only one coordinate is changing. One coordinate is changing. And when we talk about the two-dimensional motion, we say here, two of the coordinates are changing. Two of the coordinates of a body are changing. Guys, understand very, very, very carefully. Let's suppose I'll give you the example over here. Let's suppose you are throwing an object something like this. We say, sir, it will follow this particular path over here. Now, guys, if you make the x-axis and y-axis over here, this is y-axis and this is x-axis. This is x and this is y. My dear friends, I would want you guys to understand one thing. Let's suppose when the particle was exactly over here, we say how much distance it has covered in x. You say, sir, this much of distance it has covered in x. Okay. This is the x distance at that point of time. And when the particle is here, how much distance or displacement it has covered in y? You say, sir, this much of distance it has covered in y. This much of distance, displacement it has covered in y. Okay. So, my dear friends, here, two of the coordinates are changing. Means particle is moving in x as well as y. So, we say two-dimensional motion. Okay, it's a curvilinear motion. Body is moving in a curve over here. Okay. So, my dear friends, when the particle is moving along this path, means it's one-dimensional motion plus one-dimensional motion. Means two-dimensional motion is the combination of, we say x, motion in x direction plus motion in y direction. This is the motion in x, this is the motion in y. So, when you combine these two, we say it forms the two-dimensional motion. Okay. So, we say two-dimensional motion is the combination of x and y. Now, guys, let's move on to the projectile motion. Sir, is the projectile motion one-dimensional motion or two-dimensional motion? It's a two-dimensional motion, obviously. Okay. We say, let's suppose you have got a ball over here. Okay. You are throwing a ball from this point and it will follow this particular path. Now, guys, when the ball is here, how much distance it has covered in x? We say, sir, this much of distance it has covered in x. How much distance it has covered in y? This much of displacement it has covered in y. So, this is what we call the motion in 2D. Okay. We say it is a, I'll write over here. We say it is a two-dimensional motion. It is a two-dimensional motion. One more point I just want to add over here. Can I say it is the combination of horizontal. This is the horizontal motion. Ball is moving horizontally as well as it is moving vertically. So, it is the combination of horizontal as well as vertical motion. So, I'll write over here, it is the combination. It is the combination of horizontal and vertical motion. Okay. When you combine horizontal as well as vertical motion, it forms the projectile motion. Next, my dear friends. Okay, what are the different examples? You are throwing a stone in air. It will follow this parabolic path. That is a projectile motion. Okay. Even if you are, let's suppose, firing the gunshot, that is also the projectile motion. Now, guys, let's basically take a look at the first case of projectile motion that is in our syllabus, and that is what we call the ground-to-ground projectile. Okay. Is it clear till over here? I just need to know in the live chats if this is crystalline clear from every single, let me know in the chats, everybody out there. Is this crystalline clear, guys? Is this crystalline clear? Now see. Let me just tell you in this particular case, the first one that we need to talk about is, we say Ground to ground case. What is ground to ground case? Let me give you the example over here. Let's suppose you are launching an object over here. You are launching an object over here. Okay. You are throwing an object something like this. You are throwing an object something like this. And it will follow this particular path over here. It will follow this particular path over here. Guys, understand very carefully. Understand very carefully. Understand very carefully. Here, you are throwing an object from the ground and it falls onto the ground. When you throw a projectile from the ground and it will again fall onto the ground, that is what we call the ground to ground case. Okay? We say here, projectile is launched from the ground, and it falls onto the ground. Okay? So when the projectile is launched from the ground and it falls onto the ground, that's what we call the ground to ground case. Now see, let's suppose, my dear friends, this is y direction, this is x direction. Let's suppose you are launching it with an initial velocity u. If you are throwing a projectile, obviously you will give some velocity to it. What is the velocity that you are giving? That is u. Sir, at what angle? Let's suppose this angle, at what angle you are throwing it? Let's suppose that is theta. Okay? You are throwing it with u at an angle of theta. Now guys, I would want you guys to do one thing over here. Sir, what is that? What is that? See. Can I just basically, I'll just do one thing. What is that? I'll divide this projectile motion in horizontal as well as in vertical motion. Guys, see, if you are throwing a projectile something like this, we say it is covering the horizontal distance also, it is covering the vertical distance also, it is going up as well as it is going forward. So means here, I said this is the combination of horizontal and vertical motion. This is the combination of horizontal and vertical motion. Now, I'll first write over here, this is horizontal motion. Okay. And I'll write over here, vertical motion. Guys, understand very carefully whatever I am trying to say in this particular case. Okay. Horizontal and vertical motion. Guys, see, if I say you have launched this projectile over here with a velocity u and angle is theta. Guys, understand very carefully. This is the initial velocity. Can I say, sir, this u will have two components. This will be first one and this is what we call the horizontal component. If there is a vector, okay, at an angle theta, we can resolve the vector in two components, x component, y component. Remember this. We can resolve this vector in two components, x component, and this over here will be, that is uy. Okay. Now guys, if this is theta, we say this ux will be, that is u cos of theta. Guys, if this is a, then I would have said a cos theta. And this would be, that is u sine of theta. One component is what we call the cos component. Another component is what we call the sine component. This is cos and this is sine. And this is the original velocity u. Now tell me one thing, my dear friends. If I have resolved this in, we say two parts over here. If I have resolved this in two parts over here, that is horizontal motion and vertical motion. Horizontal means this, vertical means this. What if I ask you to tell me what is the initial velocity in horizontal direction? Sir, initial velocity in horizontal direction is ux, that is u cos of theta. So I'll write over here, initial velocity in x direction is, that is u cos of theta. And if somebody asks you, what is the initial velocity in y direction? That is vertical direction. So that is uy and that is u sine of theta. u sine of theta and u cos of theta. Now guys, sir, could you please tell me the answer of one question? What is that? Is there any force acting in the x direction? Guys, if you throw a body something like this, it follows the parabolic path, this projectile path. Is there any force acting in the x direction? Let's suppose when the ball is over here, is there any force acting on this ball in the horizontal direction? We say no, no force. We ignore the we ignore this air friction and all, air resistance and all. So we say force in x direction is 0. Remember this directly. There is no force acting in the horizontal direction in case of projectile motion. And when it comes to the y direction, guys, everybody knows, sir, there is a force which is acting in the downward direction. That is mg, gravitational force. And I can write over here force in y direction is what? That is m into g. M into g. Okay. Now guys, tell me one thing. Can I say over here, if there is a force, I have taught you guys Newton's laws of motion. If there is a force, we say there will be acceleration. As you might have studied, we say acceleration is force upon mass. Acceleration is force upon mass. And if force in x direction is 0, okay, divided by m, so it will come out to be, we say, sir, 0. So I say acceleration in x direction will be 0. There is no acceleration in the x direction in case of the projectile motion. What about the acceleration in y? This is acceleration in x. Sir, acceleration in y will be force upon mass. What is the force in y direction? That is mass into acceleration due to gravity. So that is m into g divided by, I say m over here. This and this will cancel, so it will come out to be g. So I say acceleration in y direction is simply g. And remember one thing, we always take this as minus g. Okay, maybe some books will say, some teachers will say, take the upward as upward motion, in that case take as plus g, downward as minus g. I am telling you guys, take minus g always. Okay, take minus g always. We'll get the correct answer. These are the different sign conventions different books follow. So I follow take minus g always. Is that clear? Why should we take minus g? Because force mg is always downwards. If mg is force is downwards, we say acceleration is always downwards. So I say take it always negative. Now guys, one more thing I just want to add over here. What is that? Guys, see. So this is acceleration in x, this is acceleration in y. Let's suppose when the particle has reached over here, at this point of time it has got the velocity v. Initially, it was having the velocity u. At this point of time, this is not the topmost point, guys. At this point, we say, let's suppose its velocity is v. Guys, tell me one thing. Can I say this is v? This will be its horizontal component over here, that is vx. And this will be the vertical component, that is vy. Let's try to find out this vx and vy. Guys, we say final velocity in x direction. I would want you guys to use this equation. V is equal to u plus a into t. You might have studied this equation. If you have to find the final velocity, you can use u is equal to u plus at. Now, since you are finding the horizontal velocity in x direction, then you have to use this equation in x direction only. Guys, remember one thing. You should know in which direction you are using the equation of motion. Y or x. You have to clarify this. Now I say final velocity in x direction is equal. Initial velocity in x direction is u cos of theta. This is u cos of theta. Okay. Then plus acceleration in x direction is how much? That is 0 into, we say, sir, time. So we say Vx will be also, that is u cos of theta, and that is ux. Means whatever is the initial velocity in x direction, same will be the final velocity in x direction. So can I say, sir, the horizontal velocity in the projectile motion always remains same. It is constant. It does not change. Horizontal velocity always remains constant because whatever is initially same is finally. Now let's talk about over here. Can I say in this particular case, velocity, final velocity in y direction is equal to, we say u plus a into t. Use this equation in y direction, So I can say over here, this is Vy is equal to, initial velocity in y direction is how much? That is u sine theta. U sine of theta. Now acceleration in y direction is how much? Acceleration in y direction is how much? That is minus g. So I'll write over here minus g into t. Guys, see, this gives us the indication that velocity in y direction decreases. Why, sir? Because as the body goes up, we say its vertical component keeps on decreasing. Sir, horizontal component will remain same. Yes, horizontal component remains same. But when it comes to the vertical component, it keeps on decreasing. Because it is u sine theta minus gt. U sine theta is the initial value. And if you subtract something from that, so it will decrease. Do you all agree? Please tell me in the chats, everybody out there. Please tell me in the chats, everybody out there. Is this clear? Guys, give me the signal in the chats. Everybody. And one more thing. Do like the session. I would want everybody of you to hit the like button. Everyone means everyone, okay? Marking the attendance is mandatory. Hit the like button as soon as possible. Now, next. Okay. Let's discuss one more term exactly over here. Let's discuss one more term exactly over here. Let's suppose, my dear friends, if somebody asks you when the particle is here, how much displacement it has covered in the horizontal direction. You say, I'll mention over here. We say displacement in x direction. Guys, in order to find the displacement in x direction, we use one formula. What is that? We say S is equal to ut plus 1 by 2 at square. Okay. Now, since we have to find how much horizontally it has displaced, so we'll use this equation in x direction. So ux ax. So displacement in x direction, let that be x, okay, or let that be sx, not a problem. And we can say initial velocity in x direction, that is u cos of theta, time is t plus 1 by 2. Acceleration in x direction is, we say, sir, 0 into t square. So this term will become 0. We say value of x will come out to be u cos of theta into t. So this is how do we find the displacement in x direction. And let's suppose if I ask you to tell me what is the displacement in y direction. What is the displacement in y direction? So in order to find the displacement in y direction, I will use the equation S is equal to ut plus 1 by 2 at square. But remember, we'll have to use this equation in y direction over here. Why? Because we are finding the displacement in y direction. It is something like this. Let's suppose when the object is over here, how much is the displacement in x? Sir, this much. Okay, let's call this as x. How much is the displacement in y? Sir, this much. Let's call this as y. X and y we are finding. So this displacement in y is y. Initial velocity in y direction, sir, that is u sine of theta. So this is u sine of theta into t. And then we say plus 1 by 2 Instead of acceleration in y direction, we say that is minus g and this is t square. So I'll write y is equal to u sine of theta minus 1 by 2 gt square. This is how you can find the displacement in x direction and displacement in y direction over here. I hope this is crystalline clear. Guys, give me the signal in the chats if everything is sorted, if everything is crystalline clear. If everything is crystalline clear. Okay. Now, let's move on to a topic that is what we call the time of flight. This is the first topic that we need to understand over here. That is time of flight. Let's suppose, my dear friends, you have an object. You are launching this object with a velocity u. Okay, at what angle? At an angle of theta. And we know that it will follow the projectile path. Okay, it will follow the projectile path. And we say this is y-axis and this is x-axis. What if I tell you to tell me how much is the time it has covered? How much is the time it has covered? Okay. What if I ask you to tell me how much time it has covered in this entire journey? So from initial point to final point, how much time it is taking in the journey, that is what we call the time of flight. So I say it is the time taken by a projectile it is the time taken by a projectile to cover the entire journey. I hope this color is visible. If not, please let me know in the chats. Okay. And how can we find this time of flight? Guys, we say use S is equal to ut plus 1 by 2 at square. Use this equation. Sir, in x or y? We say in y direction. In y direction. Okay. So use this equation in y direction and. From which point to which point? We say from initial to final point. Sir, why would I use this equation from initial to final? Because I have to find the time taken by the projectile from initial to final point. That's the reason I'm using it. Okay. Now guys, tell me one thing. Tell me one thing in this particular case. Now guys, see. If I use this equation in y direction, understand one thing very carefully. If particle is launched from this position and it has reached this position, could you please tell me in this particular case, how much is the displacement in y direction? Don't you think it is zero? Don't you think it is zero? Why? Because initially it was on the ground. Finally it is on the ground. So we said displacement in y is zero, but displacement in x is something. So if the particle was here, then I would have said yes, displacement in y direction is maximum. But finally also it is zero. So I said displacement in y direction finally is zero, is equal to. Okay, because what is displacement, guys? Displacement is, we say, difference between initial point and final point. Initially, along y-axis I am saying, it was on the ground. Finally also it is on the ground. Is equal to initial velocity, this is y. Initial velocity in y direction, that is u sine of theta. And then I say this is time is t. And then plus 1 by 2. Instead of acceleration, I write minus g into t square. I can say it something like this. Now take it from this side. So it will be minus u sine of theta into t is equal to, here this minus will come out. So minus 1 by 2 gt square. This square and t will cancel, negative and negative will cancel. Take it over here. So time will come out to be 2u sine theta. And you have got g divided over here. This will be the time of flight, that is 2u sine theta by g. So time of flight is 2u sine theta by g. This is the time of flight. This is the time of flight. And guys, is this u sine theta vertical velocity or horizontal velocity? Obviously vertical velocity. You can also write it something like this. This is 2uy divided by g. Either you say 2uy divided by g or you say 2u sine theta divided by g. It is one and the same thing. It is one and the same thing. Okay. I hope this is clear till over here. Next is what we call the maximum height. Next is what we call the maximum height. What is maximum height? Guys, see. Let's suppose you are launching a projectile over here. You are throwing a projectile, something like this. We say it will follow this path. How much high it can go? What can be the maximum possible height? That is what we call the maximum height. How high it can go? How high it can go, that is what we call the maximum height attained by the projectile. Now guys, tell me one thing. In order to find the maximum height, I would want you guys to use the equation once again in y direction. Why, sir? Because you are finding the displacement in y direction kind of. Okay. So guys, I say use v square minus u square is equal to 2as in y direction. In y direction. Now from which point to which point? We say from initial point to the topmost point. We say from initial to the topmost point. From initial to the topmost point. Guys, tell me one thing. If I use this equation in y direction, v square minus u square is equal to as. See. When it comes to the topmost point, I would want you guys to listen to me very, very, very carefully. At topmost point, we say this will have one velocity in x direction, another velocity in y direction. This is, we say, sir, Vx, and this is, we say, sir, Vy. Always remember that at the highest point, at the topmost point, this vertical velocity of a projectile is 0. This vertical velocity of a projectile is 0. Why, sir? Let me just tell you why. See. When this vertical velocity becomes 0, vertical velocity is that velocity which takes the projectile in the vertical direction, which takes it up. Horizontal velocity takes it forward. So if here velocity becomes 0, then only it will start falling back. If it is not 0, it will keep on going up. It will keep on going up. So if it becomes 0, then only it will start falling back. So at topmost point, we say, sir, Vy is 0. I'll write over here at top, we say velocity in y direction is 0. And what about this velocity in x direction? That will be u cos of theta only. Because horizontal velocity in a projectile motion always remains constant. That remains constant. So I can say in this particular case, use it over here. Final velocity at topmost point, it is, sir, Vy square minus uy square is equal to ay into sy, displacement in y direction over here. So I can say this will become 0 minus initial velocity in y direction. I have told you what is the initial velocity in y direction. That is u sine theta. In case of a projectile motion, initial velocity in y direction is u sine theta. So it will be u square sine square of theta is equal to. Now 2ay. So I'll write over here 2. Acceleration in y direction, how much? Sir, minus g. And displacement, sir, displacement in y direction. When it is at topmost point, how much displacement is in y direction? That is h. So I can say this is h. Okay, so you can write it u square sine square of theta is equal, take this minus out, minus 2gh. Minus minus will get cancelled. So it will become, h will come out to be, that is u square sine square of theta divided by 2g. This is the equation. This is the formula which you guys need to keep in your mind. And one more thing, guys, one more thing. What is u sine theta? U sine theta, guys, if this is u, we say this is u cos of theta. And which component is this? This is u sine of theta. And this is vertical component, that's uy. So I can say, you can also write it, that is, this is uy square divided by 2g. Because u sine theta is uy, initial velocity in y direction. Is this clear? Please tell me in the chats. Everybody out there, is this clear? Is this clear? Guys, hit the like button. Everybody out there. HSPs are in the chats. Huh? What's up, HSP sir? How is everything going? Now, let's move on to the next topic. The next topic we have over here, that is what we call the horizontal range. Guys, see, let's suppose in this particular case, you are throwing a projectile. Okay, let's suppose you are throwing a projectile over here. This is the projectile you are launching with a velocity, let's suppose u. Okay, and we know that, sir, it will go something like this, it will fall over here. We say how far it can go from initial point. How far it can go from initial point means this distance. This is what we call the horizontal range. Okay, how far it can go from the initial point in x direction. That's what we call the horizontal range. We say it is how far it can go in x direction. That is what we call the range of a projectile. That's what we call the range of a projectile. How far it can go in the x direction is what we call the range of a projectile. Guys, in this particular case, if you have to find the range of a projectile, I would want you guys to understand one thing. We say use S is equal to ut plus 1 by 2 at square. In we say x direction. We say in x direction. I would want you guys to use this in x direction. Why, sir? Because we have to find the range in x direction, horizontal range in x direction. Now, guys, tell me, I write over here Sx, Ux, Ax. So instead of this Sx, I'll write the range R is equal to initial velocity in x direction. So that is, we say, sir, u cos of theta. Okay. Into time is, we say, sir, t. Then we say plus 1 by 2. Acceleration in x direction is 0, time is t square. So this whole term will become 0. So this range will come out to be, that is u cos of theta into, we say, sir, t. Now the question is, what is this t? T is the time period. So what is the formula of time period? 2u sine theta by g. So I'll put it over here. We say we say time is equal to 2u sine of theta divided by g. Okay. And if we put the same formula in the above equation, so we say, so range will come out to be, that is u cos of theta instead of divided by g. Instead of this, instead of t, I can write 2u sine of theta, 2u sine of theta divided by this g over here. Okay, this is g. 2u sine theta by g, 2u sine theta by g, and u cos theta is as it is. Now guys, tell me one thing in this particular case. Can I just say, sir, take this 2 out. I can write over here r is equal to, that is 2. And it will be u cos of theta, it will be u sine of theta, and we can say whole divided by g. Guys, what is this u cos theta? U cos theta is the initial velocity in x direction. What is u sine theta? U sine theta is the initial velocity in y direction. So I would want you guys to keep this also in your box, and one more equation. I can write this ranges. That is 2, and this will be, sir, ux, u sine theta will be uy, and divided by g. I would want you guys also to put up this also in the chat, in the box. Okay, because we will be basically using all of these formulas later. Okay, now. Let's take this equation and further simplify it. Let's call this as equation number 1. So I'll write over here as we say from equation 1. If we take this equation, what is that? That is r is equal to u sine theta, u cos theta divided by g. Guys, u into u I can write also over here, that is u square. So it will be u square. And then I can write twice sine theta cos theta divided by g. Guys, there is a trigonometric identity which I would want you guys to understand. What is that? We say sine of 2 theta is equal to, that is 2 sine of theta cos of theta. 2 sine of theta cos of theta is equal to sine of 2 theta. So I'll write over here, this range will come out to be u square. Instead of this, I'll write sine of 2 theta. So this is sine of 2 theta and divided by g. So put this also in your box, because this is also the important equation which will help us to solve the questions in the upcoming time. Tell me in the chats, is this crystalline clear to each and every single student? Everyone means everyone. Is this crystalline clear? I need the signal from every single student. Guys, smash the like button, mark the attendance if you have not liked the session yet. Okay. Now let's solve some questions. Okay. Cool. This was a question which was asked in IIT 2014, but this is an easy question. That's the reason I have put up over here. Okay. If object is projected with a velocity, this is the velocity, and the velocity is given in the vector form. This is the velocity in vector form over here. Alpha I cap plus beta j cap. Then find height, maximum height, time of flight, and range. These are the 3 things that you guys are supposed to find out over here. Guys, see, it says that we have launched an object. Let's suppose with a velocity u is equal to alpha I cap plus beta j cap. This is the velocity, initial velocity with which we have launched the particle. Guys, the basic thing you might have studied, I have told you this in the vectors also. If I say there is a vector velocity v is equal to, we say 2 I cap plus we say 3 j cap. What is this I cap? We say this is that component of velocity which is along x direction. Why? Because I cap tells you the vector is along x axis. This is that component of velocity which is along y direction, because j cap tells you the vector is along y direction. So can I say in this particular case, we say Vx is 2, x direction velocity is 2, and we say Vy here is 3. Why? Because y direction velocity is 3. Same is the case over here. If u is equal to alpha I cap plus beta j cap, can I say over here, so I can say initial velocity in x direction is alpha. Okay. Can I say over here, sir, initial velocity in y direction is, we say, sir, beta. Okay. These are the two clues that we got over here. Now, if we have to find the height, or let's suppose time of flight, let's find out the formula of time of flight. What is the formula for time of flight? T is equal to 2u divided by g, 2uy divided by g. Now, I say, sir, time of flight is, that is 2uy divided by g. So, can I say this is T is equal to 2? What is the value of uy? That is beta divided by g. Done. Done. Sir, what is the value of g? Always remember, we take value of g as 9.8 meter per second square, or we take it approximately 10 meter per second square. Okay. Okay. Now let's find out the maximum height. When it comes to the maximum height, guys, could you please tell me what can be the maximum height in this particular case? Sir, what is the formula for maximum height? Come over here. Maximum height is uy square divided by 2g. So same I'll use over here, that is uy square divided by 2g. So h is equal to, what is the value of uy? That is beta. So I'll write over here, that is beta square divided by 2g. Done. If you take g is equal to 10, so beta square by 20. And I would want you guys to put up this in the box. I would want you guys to put this up in a box over here. And next one we have got over here, that is range. When it comes to the range, we say range is 2ux uy divided by g. This is one formula of range that I recently calculated. 2ux uy divided by g. Now put up over here, what is the value of ux? Alpha and uy is beta. So it will be, that is 2 alpha beta divided by g. I hope this is clear. Next, guys, we have got this question. I hope this is visible to each and every single student. Yes. Now see, at topmost point of a trajectory, its velocity and acceleration are at an angle of, okay. We are supposed to find at the topmost point of the trajectory, how much angle velocity and acceleration is making. Okay, acceleration is making. You guys are supposed to tell me that. Now guys, see. Let's suppose if I launch a projectile over here. Understand this question. Let's suppose if I launch a projectile over here. This is the projectile that you have thrown. Let's suppose initial velocity u. I see. Can I say this is the topmost point? Yes. At topmost point, you have got two velocities. Sir, one is vertical velocity, that is Vy, and we know that is 0. And another one is, we say, sir, Vx, and that will be u cos of theta. Because velocity in x direction is we say constant. And when it comes to the acceleration, I told you acceleration is always downwards. Because gravitational force is downwards, that's why acceleration is downwards. Okay. Now, if you are finding, this is the velocity at final point. Sir, this is 0, we don't consider this. How much velocity this is making with the x-axis? Okay, its velocity and acceleration are at angle. Now, this is the velocity, this is the acceleration. How much is the angle between these two? That is 90 degrees. So which option is correct? Option 90 is correct. So because you don't consider this because this is 0. So at topmost point, it has got only one velocity. That is the horizontal velocity. So that is u cos theta forward, and acceleration due to gravity is downward. So it is 90 degrees. Next. A cricket ball of mass m. We have got a cricket ball of mass m is hit at an angle 45 degrees. Okay, with the horizontal. You have got a cricket ball over here. Okay, and you have thrown this cricket ball at an angle of we say 45 degree with the horizontal, with a velocity v. Its kinetic energy at topmost point is, we have to find the kinetic energy at the topmost point. This is a good question actually. Guys, see. Guys, see. Guys, see. When it comes to the kinetic energy at topmost point, we say as kinetic energy is equal to 1 by 2 mv square. Here, mass of this cricket ball is given as m. It is given as m. And initial velocity is given as v. It is not given as u. It is given as v. Okay. Now at topmost point, guys, what is the mass? Mass is m. Now we have to find the velocity at topmost point. See, at topmost point it will have vy, that is 0. And at topmost point it will have this x component, that is v cos of theta. Sir, why v cos of theta? Guys, see, if this is v, can I say horizontal component will be v cos of theta? Yes. And we know horizontal velocity in projectile motion remains constant. So here is v cos theta, here is v cos theta, even here also it will be v cos theta. So here, can I say, so I say at topmost point, I say when it comes to the topmost point, so can I write this kinetic energy will come out to be 1 by 2, mass is m, and what is the velocity at topmost point? That is v cos of theta, v cos of, and how much is theta? That is 45. Okay, at topmost point velocity is v cos of 45 only. Now tell me cos 45 and it is square. Why? Because it is v square. So I'll write kinetic energy simply, that is 1 by 2, and then I'll write m, and this is v square cos square of 45 degrees. So it will be 1 by 2 m v square cos square 45 is 1 by root 2 its whole square, because cos 45 is 1 by root 2, and if you do the square it will become 1 by 2. It will become something like, see, this is 1 by 2. 2 into 2 becomes 4. So it will be mv square divided by 4. So mv square by 4 is the correct answer. Is that clear? Is that clear? Guys, tell me in the chats, is this clear? And if you have not liked this session yet, I would want you guys to hit the like button as soon as possible. Okay? Everyone means everyone. Hit the like button as soon as possible. Liking the session is extremely mandatory. Next, speed at any point. Guys, what is this? What is this? Let me make you understand this topic. What is this? See, let's suppose you are launching a projectile, something like this. Okay? Yes, sir. And initially you have launched it with a velocity u. You have launched it with a velocity u. And this angle over here is theta. Can I say this component of velocity will be u cos of theta? And this component of velocity will be u sine of theta. Okay? Yes. Now guys, tell me one thing. Let's suppose when the particle reaches over here, this is not the topmost point, this is any general point I'm taking. We said this particular point, let's suppose its velocity is v. Okay. Can I say this will be its horizontal component, this will be its vertical component. This is vy and this is vx. If you remember, we have already calculated the value of vx and vy. Value of vx is u cos theta. Value of vy is u sine theta minus gt. I'll copy it as it is because I'll not explain once again. So we say, I'll write over here, we say as when it comes to the vx, that will be u cos of theta because velocity in x direction remains constant. And when it comes to vy, that is u sine of theta. That is u sine of theta. V cos theta, u sine of theta. Just a second. Okay. Now, guys, we got the value of Vx and we got the value of Vy. Now we have to find this velocity. And let's suppose this angle over here is alpha. Okay. Guys, see. Can I say in this particular case, sir, if we join this, if we find the resultant of Vx and Vy, that will be, sir, V. Or you can understand it something like this also. If you resolve V in two components, it will be Vx and Vy. Okay? Or you say, if you combine this and this, it will form V. So can I say, so I'll write, sir, this velocity V, it will be simply this velocity plus this velocity, that is Vx, and plus we say, sir, Vy. Now, Vx is in the x direction, so I'll write I cap. Vy is in the j direction, y direction, that's why I write over here j cap. Okay. Okay, yes. So this is basically the velocity over here. That is Vy into j cap. Now guys, tell me one thing. I would want you guys to understand one thing. Can I say in this particular case, we can write this velocity V is equal. What is the value of Vx? Sir, that is u cos of theta into I cap. And then we say plus value of Vy is, and this is u sine theta minus gt. Sorry, I forgot. U sine theta minus gt. So that is u sine of theta minus gt. Okay. And you write over here j cap. Because this is the velocity, final velocity in y direction. It is not initial that we are talking about. So this is I cap, this is j cap. And this you can put up over here. This you can remember over here. In this particular case. Now guys, if you have to find the magnitude of this velocity, sir, how do we find the magnitude of this velocity? That will be under root of this vector square plus this vector square. That is Vx square plus Vy square. So that is u cos of theta its whole square plus we say u sine of theta minus gt whole square. This will be the magnitude of the velocity in this particular case. This will be the magnitude of the velocity in this particular case. Okay. This is the velocity vector and this is the magnitude. And even if somebody asks you to find this alpha also, find alpha also. Guys, see, how do we find the alpha? I say we have got velocity V over here. This is V. And this velocity over here is, that is Vx, and this velocity over here is, that is Vy. This angle is alpha. Now, can I take this vector from here to here, sir? Is it possible? Yes, we can do it. It is what we call the parallel shifting of vectors. This is Vy. Now, tell me from this triangle, what is the value of tan alpha? Sir, tan alpha is Vy that is perpendicular by base. So can I say here tan of alpha that is perpendicular by base, that is Vy divided by, we say, Vx. And I can write it, that is tan of alpha is equal. What is the value of Vy? That is u sine theta minus gt. U sine of theta minus gt. And what is the value of Vx? That is u cos of theta. Okay. Okay. Is this clear? Is this clear? Let's take a look over here. Guys, answer this question which is mentioned on the screen. I would want you guys to tell me the answer of this particular question which is mentioned on the screen. Come on. An object is projected with a velocity of 30 I cap plus 40 j cap at t is equal to 0. Initial velocity is given as this. Then find the angle of projection. You are supposed to find theta, maximum height, time of flight, and range. These are the 4 things that you guys are supposed to find out in this particular question. So I would want you guys to do it as soon as possible before I do it actually. Okay, guys, see. Let me first draw the figure over here. There is an object which is launched something like this. There is an object which is launched something like this. With what velocity? We say we have launched it with a velocity v is equal to, that is 30 I cap plus 40 j cap. This angle is, we say, sir, theta. You have to first find the value of theta. Can I say in this particular case, sir, initial velocity, this will be the value of, sir, ux will be, sir, in this case 30. Why? Because whatever is mentioned with the I cap, so that is the velocity in x direction. And whatever is mentioned with the j cap, that is the velocity in y direction. Okay. Now, guys, tell me one thing. Tell me one thing in this particular case. So, if this is theta, we say, sir, this will be its initial, let's call this as u. This will be, sir, ux, and this component of velocity, will be uy. Now, can you tell me what is the value of tan theta? You say, sir, tan of theta will be simply, that is perpendicular by base, that is uy divided by ux. So, how much is that? Uy is, we say, sir, 30 divided by, we say, sir, 40 by 30. That is 40 divided by 30. This and this will cancel. So, value of tan theta comes out to be 4 by 3. Value of tan theta comes out to be 4 by 3. Guys, see, if we make a triangle over here, okay, and if I say this side is 4, this side is 3, and this side is 5, then we say this angle is 53 degrees. This is what we call the 53-degree triangle. And if I, let's suppose, say I have got another triangle over here, we say this side is 3, this side is 4, and this side is 5. And then we say this is 37-degree triangle. Now, can you tell me in this triangle, what is the value of tan 53, perpendicular by base? So, tan 53 is 4 by 3. So, I can say instead of 4 by 3, I can write tan of, so this is tan of theta is equal to tan of 53 degrees. So, here I can write theta is equal to 53 degrees. I hope this is clear till over here. Yes, a lot of people are giving me the answer 53. Now, what is the value of, we say maximum height? What is the value of maximum height in this particular case? We say as, when it comes to the maximum height, h max, what is, how to find h max? Uy square divided by 2g. So, I'll write that is uy square divided by 2g. What is the value of uy? That is 40. So, it will be 40 square. 40 square divided by 2 into, we say, sir, 10. G is 10. So 40 square is 1600 divided by 20. This and this will cancel. So this will cancel. So it will come out to be 80 meters. So how high it can go? Maximum height is 80 meters. What is the value of time period in this particular case? Let's find the value of time period. When it comes to the time period, I say time period is 2uy divided by g. So time period is 2. What is the value of uy? Uy is 40. So I'll write over here 40 divided by, we say, 10. This and this will cancel. So t will come out to be 8 seconds. Now, last one, that is what we call the range. So can I say range in this particular case is simply that is 2 times of ux uy divided by g, because we recently studied this formula. So can I say, sir, this will be 2 into, what is the value of ux, sir? That is 30. What is the value of uy? That is 40 divided by, we say, sir, 10. This and this will cancel. So 60 and this will come out to be 240 meters. So range is 240 meters. I hope this is crystal and clear to each and every single student. Is this clear? Is this clear, guys? Now see, two objects are thrown up at an angle of 45 degree and 60 degree respectively with the horizontal. If both attain the same vertical height, then the ratio of magnitude of velocities are. Guys, see, the question says that in this particular case, they have thrown the two objects. This is the first object and this is the second object. Okay. They have thrown the two objects. It is saying that let's suppose first one is attaining the height h1. Second one is attaining the height h2. They are saying that both are attaining the height h1 is equal to, we say, sir, h2. Two objects are thrown at an angle of 45 and 60. So we say this is at 45 degree, another one is at 60 degrees. Okay. So first one is attaining the height h1, second one is attaining the height h2, but both are attaining the same vertical height. Or let's suppose in some case this happens. The ratio of the velocities, let's suppose we have launched this with a velocity u1, we have launched this velocity u2. So we are supposed to find the value of u1 divided by u2 in this particular case. What is given in the question is that that is height is same for both. Height is same for both. Guys, see, can I just write over here, we say as if maximum height of first one is equal to height of second one. How to find the height? Sir, value of height we can write u1 square sine square of theta 1, because height is u square sine square theta divided by 2g. So for first projectile I am writing u1 theta 1 because theta is 45 and is equal to, how to write the height of the second one? We say, sir, that will be u2 square and then I write sine square of theta 2 divided by, we say, 2g. Now can I say over here, guys, can I say over here, this 2g and 2g will cancel. So I'll write this u1 divided by u2, this square is equal to, and here I'll write sine square of theta 2 divided by sine square of theta 1. Something like this. Now, this square. So I can write it u1 divided by u2 is equal to, that is sine of theta 2 divided by, I'll write sine of theta 1 over here. Okay, yes. Now guys, tell me one thing, u1 by u2, I'll write, sir, u1 divided by u2 will come out to be sine of theta 2. What is the value of theta 2? That is 60 degrees. So I'll write sine of 60 degrees divided by sine of 45 degrees. So I'll write u1 divided by u2 over here. What is the value of sine 60? That is root 3 by 2. What is the value of sine 45? 1 by root 2. Now, if you take this in the numerator, it will be root 3 by 2 into root 2 by 1. I can further write it something like this. This is u1 divided by u2 is equal to root 3 by 2 into root 2 by 1. Now rationalize, multiply with root 2 and divide with root 2. This root 2 into root 2 becomes 2. That 2 will cancel with this 2. So what will remain? Root 3 by root 2. So u1 divided by u2 will be root 3 divided by root 2. This is the answer to this particular question. Okay. I think that's all for today, guys. So it will take one more lecture, part 2, second part it will take. So that's all for today. So thank you so much. And guys, I would want you guys to hit the like button before leaving. And one more thing, I would want you guys to write down in the comments later on when we end the live stream how was the session and all. Okay, do let me know in the comments later on how was the session, did you like it or not. And before that, I just want to tell you one thing over here. What is that? What is that? That is guys, that is, we say the lowest prices on NEET UG subscription. The lowest prices on NEET UG subscription. If you have not taken the subscription as of now, so I would want you guys to take it. Okay, so it is only for 4,999 rupees, and this is basically valid till 17th August. Okay. Now, my dear friends, take it as soon as possible. And second thing is, we have recently launched this Phoenix Pro batch. If you have not joined this particular batch, you can join it as soon as possible because the batch is live. We are teaching completely in this particular batch. Okay, so join it as soon as possible. And one more thing, do like this particular session. Okay, and then leave. So take care and bye bye. Thank you so much. The notes will be shared in the Telegram channel. Do join our Telegram channel. My Telegram channel is personally, that is YAWARMANZOOR, Yawar Manzoor. Okay, so t.me/Yawar Manzoor. Okay, so thank you so much. Take care and bye bye.